Astronomy, from my perspective, astronomy is just the study of everything that we look up and see in the sky. Scientists have some artificial construct that where our atmosphere ends and space begins. Astronomy is that, from the moon to the sun to the planets. The story I usually tell is if I'm on a plane and I want to have a conversation, I say I'm an astronomer. If I'm less interested in conversation, I say astrophysicist. I think in reality today, there's no real difference. There's some historical context where there were astronomy groups with telescopes doing observations. In the physics department, there were scientists doing the maths and the experiments related to astrophysics. Those were the distinguishing features of the two fields. But today, it's all the same. I think if we talk about astronomy as what we can see, then yeah, it depends on who's doing it. It depends on our relationship to the night sky, whether we can see the North Star or the Southern Cross, whether we see the Magellan Clouds or Andromeda, and all these different things. And it does depend on time. We somehow could observe the universe a second after it was born. It would look very different, but it depends on when and where we are. Almost the entirety of our field is defined by using light to understand the universe. Today's a little different thanks to neutrino experiments and gravitational waves and the hunt for dark matter, but almost everything else is light. And almost all that light comes from stars. We want to understand things like the shape of our Milky Way, we look at stars. The shape of a halo of our galaxy, we look at stars. We look for exoplanets, we're looking at stars. I think when we look at stars, it shares all these stories, because no two stars are the same, really. So many scientists are looking for stars like our sun, but it's hard to find one exactly alike. So it's like trying to understand people. For many situations, our sun is sort of the average, but it has a perfect mass. It's not, if it were much more massive, it wouldn't live very long, so we wouldn't be able to be here. Or much smaller, it would live a very long time, but it wouldn't generate that much heat. It would be very red and cool, like cool as saying 3,000 degrees Celsius. So in many respects, our sun is sort of the average. It doesn't really stand out. It doesn't have like a whole bunch of other stars orbiting it, because we're the only planets we know of with life. I guess in that respect, our sun is very special. I tend to jump around different stars, but I like also trying to understand the most massive stars that are 10 times more massive than our sun, and stars that are even 100 times more massive than the sun, because these are these really hot, we call them O-type stars. They look very blue, they live fast, die young. They're kind of rock stars. We get to learn so much about these stars because they're doing all these different things, because they're so massive that when they spin, they deform their shape when they spin fast enough. We get to learn about how they rotate. We learn about the fluid dynamics, magnetic fields. On the other hand, I also like studying supergiant stars like Betelgeuse. Betelgeuse is this great red supergiant star that sits in Orion, and it's so beautiful when you see it on the night sky. But for most astronomers, all we're waiting for is for the thing to explode. So we know it's going to explode soon. We know that pretty much every star that's more massive than 8 times the mass of our sun will end up exploding as a supernova. And this has to do with how stars form elements in their core. Stars like our sun generates energy to give us our light from taking 2 hydrogen atoms, banging them together to eventually create helium. And that gives off a little bit of energy that turns into photons that eventually reach us. But more massive stars, when the core runs out of hydrogen, they're able to fuse helium, they're able to fuse carbon and oxygen, and so on until you reach iron. For most people who study quantum mechanics, we realize that when iron tries to fuse, it's a problem because it takes energy away from the star as opposed to creating energy. So when that happens, there's no way for the star to support itself anymore. It collapses onto itself, creating perhaps a neutron star or a black hole, and then a shockwave creates the explosion. And because we know Betelgeuse is much more massive than 8 solar masses, or 8 times the mass of the sun, we can be fairly certain that it's going to explode eventually. And because we know it's cool, it's only about 3,000, 3,500 degrees Celsius, and the amount of light it emits, we can guess that it's very well beyond fusing hydrogen. It's probably burning helium or maybe burning carbon, but it's getting very much closer. And we know the timescales for burning these heavier elements. It gets shorter and shorter and shorter. And by the time it gets to like oxygen, it's only lasts a year burning oxygen, or a few tens of years. And so we know it's getting close, but we don't know enough precisely about the star to be able to say exactly when. We don't have a very good certainty of how far away Betelgeuse is, even though it's one of the closest stars. We don't necessarily know how massive it is because it's a single star, and we measure the mass of stars by gravity. So we need to see them interacting with other stars to do this. And so we have to sort of guess what its mass is based off its amount of light and amount of temperature we see, and sort of fitting our stellar evolution calculations by doing computer modeling. So we can't do that very precisely. So we have very limited knowledge. Today, well, we know that planets are actually fairly common, but 20% of stars have planets. But we still only know of one planet with life. We still only know of one planet with intelligent life. I'm sure there are people who listen to this who may question even that assumption. And we only know of one planet with possibly having a civilization, and we don't know how long that civilization will last. Frank Drake's whole idea is built on this premise that civilization and intelligent life being human, and being human in this technological world that was, the 1950s US or 1950s Canada. And so it was very much based on this very Eurocentric, Amerocentric kind of perspective at the height of, of scientism in the US. I think today we can actually broaden this out because we live in Canada. Canada is Indigenous lands. Indigenous people have been here since time immemorial, whether it's Mississaugas or Haudenosaunee, Anishinaabe, and so on. And they were civilizations. And when we talk about intelligent life, well, humans might not be the only intelligent lives. There may be other paths to intelligence. If we talk about intelligent life being using tools, well, we know crows and whales and monkeys all use tools. If we talk about intelligent life through emotions and self-awareness, well, we know that of killer whales who carry their dead children along with them, who mourn. We know that dolphins can laugh. And so self-awareness seems pretty common. So our definitions kind of have to broaden. And even the definition of what is life from many Indigenous perspectives can be very important and very crucial to think about, because we tend to think of, NASA tends to define life by something that, consumes material and reproduces and various other things. But no matter how well NASA defines life, there's always an exception. Like a virus doesn't reproduce without a host. Self-replicating robots aren't necessarily self-aware, but they replicate. But for many Indigenous peoples, life is sort of comes from relationships. Being in relationships with the salmon, the bear, the elk, so on. That's part of being alive. Where I'm from in Mi'kmaq, with the Mi'kmaq people, we're connected to the bear very much as part of our cosmology, or connected to the cod and lobster and the other fish as part of our ways of living. Being a life form is part of being in that relationship. In that respect, maybe life goes beyond carbon-based and becomes something more broadly defined. Definitely, we have to conclude there's life out there. I think just the philosophy that there's billions of stars in our galaxy and we're the only life forms, that's, boring. I think assuming that we're the only life forms in the galaxy is a very difficult pill to swallow, because it's just so unlikely. There very much certainly could be life in other exoplanets in Andromeda and in the Magellan Clouds potentially, and so on. There are questions of how easy it is to form planets when you have less iron and carbon and oxygen. So you sort of have to have some level of cosmic evolution perhaps, but almost certainly other galaxies will have life as well. To be honest, we still haven't actually found a planet where we can actually safely assume that it's very much like Earth. When we say we find an Earth-like planet, what we're saying was we're finding a planet that's roughly the same size and radius as a sphere as the Earth. That doesn't mean it's not made of a diamond or is a ball of gas or something else. We are just at the point of getting bulk properties. I think in the next generation, we'll be getting to the point where we can start asking, are we seeing oxygen? If we see oxygen, that's a good sign of life. As we know on Earth, the oxygen in our atmosphere was created by life forms being here, anaerobic life forms. If we see lots of methane or something, maybe that says something about life, or maybe it's a natural process. And we saw this controversy with things like the idea of the anomalous signal on Venus, where they saw the signal of this one kind of molecule that they couldn't explain away. And to the author's credit, they didn't really say it was necessarily life, but that it could be. When the data analysis was redone by other people, sometimes that signal went away. And so it's hard we're not even really at the point of having a signal where we can be sure that we're getting it right. I think with the search of life in our solar system, we tend to focus on Mars and Venus because they're in the habitable zone, where we're just the right distance from the sun, where we know that water can exist as a liquid and a solid and a gas. But probably the best place to find life in our solar system outside the Earth is around the moons of Jupiter. We know those moons like Galileo or Ganymede, it's solid core, an ice shell. That seems like a very good spot to find life because it has all the ingredients with ways of mixing minerals in the water, so therefore you may be forming DNA. And I think that's actually the better place to search for life. Like Mars might have life, but it's going to be hard to find. But I imagine if we can go to Europa and Ganymede, we could probably go ice fishing and find life. One of the funny things about science and astronomy is that we tend to think of ourselves as being very objective, and we're not really part of our observations and all that stuff. But the fact that we live in this universe where we can actually see these things and have some interaction, it's so wonderful, because if we do discover life on another planet, then we have to reevaluate our own place on Earth. If we find microbial life on Mars or some sort of fish life on Europa, then we have to sort of rethink all these different things about our understanding of the universe and our place into it. and our relationships with it, because it's very much problematic. We're currently in a world where we're slowly burning it up with fossil fuels, where we got rich people sending rockets into space all the time on some sort of weird rich competition. I think it's the relationships that between our solar system and us and as a society and as a species is very valuable as part of our makeup. So I think is also about understanding us. One of the big issues right now with space exploration is that it's very much dominated by a few people. And to be honest, those people are more privileged. They're white. They're almost entirely men. There's a very certain power dynamic in play here. And there's a lot of voices in the discussion of space exploration and settlements that aren't there. And this is a problem because we all see the night sky. It's part of everyone's being. Indigenous peoples from other countries share the night sky. And we all have a relationship with it, whether it's our stories of the moon and the stars, whether it's our use for navigation, having all these satellites, particularly low Earth orbit satellites that you can see with the unaided eye on dark spots, or the idea of mining on the moon. These are all being dictated by people with certain levels of power. So right now, my biggest concern with space exploration is being dictated by people with bigger wallets. When we talk about astronomy and space science and space, we have all these kind of knowledges and understanding, and we talk about them in terms of a certain perspective. And that perspective tends to be Eurocentric. So for instance, let's talk about the constellations. In the Northern Hemisphere, we have the Big Dipper, or Ursa Major if you prefer. We have Cassiopeia, Cepheus, we have Draco. And they all come from this one historical context, largely Greek and Roman astronomy. And the Greek and Romans told great stories about these things. Now, as you travel through time, those constellations sort of get maintained through star maps in European courts. They became part of navigation in the oceans when we had first colonization of the Americas and then the slave trade. And they kept existing until the 20th century when the International Astronomical Union formed, which was great. That was a way of supporting astronomy worldwide, but at the time was essentially a bunch of white dudes from Europe. And they formed a committee to, let's simplify the night sky, and we'll have 88 constellations, because we got all these overlapping constellations. So they get together in a room, and it's a British guy, it's a French guy, and it's a German guy, and they dictate constellations, and it's a bad joke. There are people around the world, whether it's in Asian countries and Asian regions, in the Northern Europe, indigenous peoples, in the Americas, indigenous peoples, who have our own stories, our own constellations. But we don't see them anymore. If I open a textbook, I see Ursa Major. I do not see my constellations from Mi'kmaq or Haudenosaunee constellations, or constellations of Salish or Inuit constellations. That's erasing our stories, and that's colonialism. We have colonialism today with how we deal with telescopes. All of our telescopes that particularly Canada are part of are on indigenous lands. Across this country, Canada, whether it's in Hawaii, whether it's in Chile. And then we have the future of colonialism, which is going to space. The way we do space exploration and space settlement is the exact same narrative that we did when Canada and the US was being settled. The pioneer, the frontiersmanship, the man versus nature element. I'm Mi'kmaq from Titumaguk. Titumaguk is the island in Newfoundland. We didn't grow up in a community because there was a lot of settlements. The Mi'kmaq were spread out across the island. So I grew up basically in suburbia, watching Mr. Dress Up and Much Music. And so I didn't really have a strong connection with my heritage and where I come from. One of the best parts of Western Newfoundland, other than Gross Mourne and the skiing, is the clear night skies. Seeing the Milky Way and all the stars, meteor showers, and you see this blanket of stars. It feels like home. That's kind of relates this mystery of everything we have with relates to astronomy and understanding where we're from on Earth. And more recently, I'd never really thought about what it meant to be Indigenous in astronomy and physics until, I attended a national conference of Canadian astronomers in Winnipeg, and a Cree astronomer, who worked in communities across Manitoba. He stood on a podium and started telling us stories. He's telling us the Cree stories of the Bear and the Hunters. He told us the Cree story of 3 dogs. He told us Cree stories of the Sweat Lodge. And I was just dumbfounded. I didn't know my own stories. Knew nothing about it, and why didn't I? I was teaching history of astronomy, teaching about Aristotle and Galileo and Copernicus and Ptolemy and Newton and every other white dude in the past 1,000 years. Where was the indigenous knowledges? That kind of inspired me to really dig in and start learning, so that not only so I can learn about indigenous astronomy, but also reconnect where I'm from. As I'm getting older, it's becoming more important to know where I come from. It's not just the stories anymore, it's indigenous methodologies. How do we do science that's not necessarily the same way? We don't many indigenous peoples, and there's no one pan-indigenous knowledge system, but many indigenous peoples don't necessarily use the scientific method to understand the universe, but different other ways, through long observation, through learning in time and oral transmission of stories, and thinking about relationships and all these different possibilities. In my mind, all these different doors opened, and it just felt like I was rewiring my brain from the traditional Western science to maybe something else. I really began to fall into that kind of behavior there and learning my own stories. And as today, I still don't know many Mi'kmaq stories other than one or two. Western science, we have to be objective. How often do we see this thing that if I have an experiment, you should be able to reproduce it from my notes verbatim, no matter what, and get the same result? That's not necessarily something many indigenous peoples do. Everything's about relationship. Where I am, what I observe, what I experiment, it's not going to be the same thing that what you do, what you see, what you observe, because we're different people. So I think that relationality is very important for understanding where we are and where we're going. And I think Western science kind of bumps up this in astrophysics when we talk about, the fact that the universe looks the same in all directions, and that kind of bugs us, or the fact that the universe is just too perfect. If certain quantum mechanical properties change slightly, we can't necessarily exist. So therefore we have to get out of that special realm. We tend to think of humans as the apex of nature and the world. So humans are above the animals, that are above the plants, that are above the bugs, that are above the dirt. And many indigenous peoples don't see that. There are scholars who talk about the fact that we have treaties with Salmon Nation or Bear Nation or Cedar Nation, thinking about these other species as having rights to the land equal to our own, which for astronomy might not be obvious how that affects us. But if we think about environmental science and climate change, maybe we can see how that could be a very valuable perspective.